Hello everyone. The question that I'll be solving today is equality equity. It's, now, in this question, you will be given two integers a and b, and you need to make both of them equal. Like you need to make the difference between a and b negligible. Like on the first move, you have to add one. On the second move, you can subtract two from either of them, either from a or either from b. In the third move, you will be adding plus 3, and in the fourth move minus 4, and in the fifth move plus 5, so on and so forth. You can apply those operation on either a or b. Now you need to calculate the minimum number of moves to make a and b equal, and print minus 1 if they can never be made. So this is not possible if you will be able to make both of them equal for any condition. How it will be possible? Because 1 plus 1 we are doing plus 1, then minus 2, and then plus 3. If you can see that this is contributing 1 to your number, like minus 2 plus 3, and then again plus 1. So you can make a and b equal by doing plus 1 to the number which is lesser. Yeah, plus 1, then again plus 1, so on and so forth. So you will be able to make both of them equal in any condition. Now there is a pattern. Let me make it more clear. On the first chance, you will be doing plus 1, then minus 2, then plus 3, minus 4, plus 5, and then minus 6. If you observe the sum of these numbers, by ignoring that minus sign, like this is 1 for sure. Now 2 plus 1 is 3, 3 2 5 1 6, then 10, 15, and then 21. Now if you want to know, we need to make the difference as 0. So the difference between two numbers is 0, then you don't have to apply any operation, like 4 and 4 are 0, so the number of moves is 0. Now for 5 and 4, to make them equal, you need to remove this difference 1. So you can apply this 1. But if you want to remove 2, then you need to take a help of 2 minus 1 minus 2 is, I want to know for which move 2 can be like solved. Like the if the difference between a and b is 2, then which move is needed to resolve that difference? So we can see like 3 minus 1, 3 and minus 2 is 1, and this is also 1. So this can solve the difference 2. So 2 can be solved by the third move. 1 can be solved by the first move only. Now 3. How can we solve 3? 3 minus 2 is 1. We'll be subtracting minus 2 from the bigger one and then adding plus 1 to a smaller one. So the total difference between those two numbers can be resolved with a difference 3. So this is 3 minus 2 and plus 1. Now if I want to resolve the 4, 4 can be resolved by this only. 5, 5 could not be resolved by this. For 5 we need to move to 5. For 6, this could be resolving like 3 plus 2, 5, 1, 6. You have to add plus 3 and plus 1 to one number and minus 2 to other. So, and the total difference that you will be creating is 6. So 6 can be resolved by this, the third operation. 3 can be resolved by this, and 5 can be resolved by this. And the total sum is 10. So 10 can be resolved by this. By subtracting minus 4 and by subtracting 4 and 2 from 1 and adding plus 3 and plus 1 to another. So the total difference 10 can be resolved. Now for 8 also this will be helpful. And now 2, 4, 6, 8, 10. Now if I want to know 1, 2, 3, 4, 5, 6, 7, 8, 7. 7 can be resolved by this. 8 is over here. And for 9, total difference is 15. 9 can also be resolved by this. This can resolve up to 15 because the total difference, the maximum difference that it can resolve is 15. So 5, 7, 9, 11, 11, 13, and then again 15. This can resolve. So there is a pattern that you could observe. If the sum is 1, it will be, it is odd. So it will be resolving all the odd differences up to 1. So it is resolving 1. Now the total sum is 3. It is odd. So it will be resolving all the differences up to 3. And we got our 3. Now it is even. And it will be resolving all the differences up to 6. And it is even. So 2, 4, 6 that was pending. Now for 10, up to 10. So it's 8 and 10. Now it's odd. Again, it would be up to the odd. Now for 6, it's odd. So it will be resolving up to 21. I got 5, 7, 9, 12, 15 for this. Now, and then again 17, 19, 21 can be resolved by 6, by the sixth move. So we got our pattern. Like we need a, if it is odd, the difference, we need a largest, not like the odd number which is greater than or equals to uh, the difference. If it is even, we need we need a even sum which is greater than equals to the difference. So we need the we know the summation like n into n plus 1 by 2 for the in natural number. So using that we can calculate the first odd or first even. So, and one more thing is that you could observe that the first two are odd, then again even, again you're getting odd. So that's a pattern like two odd, two even, two odd, two even. So if you got some, let's say, if my difference is odd, and you got that, okay, my difference, let's say, is 7. So 7 can be resolved by 5, but I got a summation of 10 over here. Then how could I reach to an odd sum? I know my odd sum could be one far away or could be too far away. Because if I'm standing over here, then I could be too far away from an odd sum. So by adding one or by adding two, we can reach to our destinated sum. Now let me show the code and it will be more clear. First, I have taken an input and then the if the difference is 0, then we have to just output a 0 and return. Then I'm just taking a random range to do a binary search. Now I'm taking temp. Temp is the move that we may need. Now for that move, I need to calculate the natural sum up to that mid position. Now temp is the number of total difference that we can create. Mid into mid plus 1 by 2. That is the sum of n natural number. Now if it is greater than d, it means this could be our answer. So I have just included that mid to my count and sum as temp, like the total sum that I got. and j. I've reduced my j. So if I could get the minimum number of more minimum, then I could get that also. So if d, the difference, is odd, then I need a odd sum. So if my sum is odd, then okay, I got my answer. So that is count, because I have stored that mid to my count. If it is not odd, then it could be one far away or two far away. So I've incremented count by one. Then again, I've counted the total number of moves that it could contribute. So if it is again even, I want a odd. So it means it is too far away. So I've incremented count again by one and just printed it. Then if it is even, then I need a even sum. If it I got my even sum, then I'll be printing that count. If it is not, it could be one far away or could be too far away. If it is one far away, then again should be even. But again, if it is not even, then I need to increment again this number, and I'll be printing my answer. So that's it for the video. Thank you for watching.